Periodically, a neuron produces an action potential near the cell body. The voltage spikes from 70 millivolts to around plus 40 millivolts, and then back down again. This pulse propagates down the length of the axon portion of the neuron until it reaches its terminals. Within these terminals are storage sites called synaptic vesicles. Every time an action potential reaches one of these axon terminals, some of these vesicles burst open, releasing the neurotransmitter stored within them. The neurotransmitter is released into the synapse, a microscopic gap between one neuron and the next. The neurotransmitter diffuses across the gap and adheres to receptor sites on a neighboring neuron, called the postsynaptic neuron. As the neurotransmitter adheres to the surface of that postsynaptic neuron, it influences the likelihood that it will produce an action potential of its own. Different neurons contain different types of neurotransmitters. Some are excitatory, that is, the more excitatory neurotransmitter released into the synapse, the more likely is the chance of a postsynaptic neuron action potential. Some neurotransmitters are inhibitory, that is, the more inhibitory neurotransmitter released into the synapse, the less likely is the chance of a postsynaptic action potential. Reuptake is the final step in the neuronal communication process. Our brains invest a great deal of energy to produce neurotransmitters. Rather than use them once and then discard them, neurons recycle the neurotransmitter. After the neurotransmitter is released from the synaptic vesicles, it gets absorbed back into the synaptic vesicles. If the action potentials of a neuron slow down enough or stop entirely, the amount of neurotransmitter in the synapse itself will quickly drop down close to zero.